All right, so in the first video, we went ahead and built our environment. We have it set up with SSH and basic Linux utilities. That includes OpenSSL, and OpenSSL is what we're going to be focusing on today. We're going to be building a certificate authority. I use these for my clients to handle .internal and .local domains, which you can no longer get from public CA. So to start, the first thing we're going to do is build a config file. So let's just go ahead and start from scratch. There's going to be some things that we're going to paste in from the default config that comes with OpenSSL, but for the most part, this is going to be kind of tailored to our needs. And I'll go over some of these options as I paste them in. All right, so our working directory, etc ca, right? That's the default location that this stuff is going to install in. We're saying that our default ca is going to point to a reference point called ca default, which is right here. We can see that all of these files are going to be located within $dir, which is ECCA. We can see our default days is 1840, which is, what is that, 5 years? Our default MD is going to be SHA-256. SHA-1 is deprecated, so this is the minimum you want to do. We're going to use default CA for our name options and certificate options. Our policy is going to be called policy OPT for optional, which we haven't added in yet. And then copy extensions is going to be copy. Now, I want to comment on this real quick. If you get a CSR that has subject alternate names in it, typically speaking, they're going to get stripped out by a CA. And the reason for that is, if you don't validate each signing request, then somebody could go into their certificate and put CA equals true on the CSR, and now you've made them a subordinate CA to you, and they can start issuing certificates under your name. So copy extensions equals copy will allow you to trust the subject alternate names that are in a CSR, but make sure that you pay attention to what you're signing when you get the requests. If you're using this for a .internal, .local domain, it's not a big deal. But this is just something that you should be aware of because it can cause a nightmare. All right, so now we're going to go ahead and make that policy opt section that you saw there. And I'm just going to paste it in here, and then I'll explain what it does. All right, so we've created it. Basically, it says that all of these items are optional. By default, policy strict says that the country name, the state, and the organization name all have to match. So the signing CA's settings for that have to match any CSR that it's signing, or else it'll fail. By making it optional, it just gives us some wiggle room, right? And since this is for internal only use, not a big deal, right? All right, so next we'll create our REQ section. And you can see here our default bits are going to be 2048. The key file is going to be keyed up default MD SHA-256. Probably looks familiar. We're going to use UTF-8 only, and our extensions will be v3 rec. All right, we'll go ahead and make our distinguished name section next. All right, and you can see here we've made our distinguished name section. This gives you all the prompts that are going to come up, so you can edit these to be whatever you want them to show. You set your mins and maxes. And then down here, we've set default variables. So our organization name is going to default to Client Tech LLC. Our city name is going to default to Chicago. Our state name is going to default to Illinois. Our country is going to default to the US. Now, you can, of course, change these, but these are going to be the presented defaults, which can save us some time when we're generating certificates. Now we'll go ahead and make our v3 CA and our v3 rec sections. v3 CA, of course, just says CA is true. Pretty easy. v3 rec, this is where we're going to do our normal certificates. It says the CA is false, and it also says subject alternate names will come from this alt name section. So let's go ahead and create that. For example, I think we're going to use client.local as our internal and client.com as our external. All right, and so let's look at how we want this to work. Publicly, we're going to have a website, and we'll call it www.client.com. All right, but we also want the certificate to be valid for client.com. And internal browsers or users are going to go to it by browsing to client.local. So we want to trust client.local as well, and also www.client.local. And then rare IT guys who just love numbers might want to browse to it by IP, which in this case is 10.10.0.50. So we want the certificate to be valid for that as well. Now, maybe there's an external IP address. Let's go ahead and add one. Let's say the external IP address is 213.47.120.9. All right, now this certificate would also be valid for that. So now we have our config file here, all right? And we will use that to do some other things. So let's get started though. Let's go ahead and create our key. Now remember, our keys are always secret. You don't want them to leak out, all right? So we're gonna generate an RSA key. We're gonna call it rootca.key. You can tell this is the root CA here. And there we go, we've got our key. Now we need to generate our certificate and self-sign it. ca.key, we want it to be SHA-256. Let's use our 1840 days. And we're going to call it rootca.pem. All right, now it's going to use the OpenSSL configuration we made. So it shows our company name, Client Tech LLC. Organizational name, we'll leave that blank. Email address, we'll leave that blank. Locality, Chicago, Illinois, US. Now, what's our common name? This could be your host name and IP, or whatever. Let's just call it root CA or something. So basically, when you look at the certificate, it'll show up as something like root CA Client Tech LLC. You can change that up so it looks a little better, but that's what we got. So now you can see we've got our root CA certificate and our root CA key. Now, this is a self-signed root CA. So what do we need to do? We need to trust it, all right? It's not going to be trusted by browsers by default. The easiest way to do that is to push this out via a GPO to all of our client systems, all right? So we pull up our group policy manager here, and we're going to go to our default domain policy, for example. Go ahead and edit this. Make this a little bigger here. See? All right, and so it's going to be under computer configuration. We're going to go to policies, Windows settings. It's going to be under security settings. We scroll down a little bit, we're going to see public key policies, and then trusted root certification authorities. All right, so what we could do is download this certificate. Root at all right, so we've downloaded that to our desktop. And now we're going to go ahead and import that. So we're going to right click Trusted Root Certification Authorities, hit import, local machine. We're going to browse to our desktop. Tell it to look everywhere. And we've got a file called rootca.pem. And now we've imported this. So we've got rootca here. Now, it's saying that it's not installed into Trusted Root Certificate Authorities, and that's true because we put it into our GPO, but my system hasn't processed this GPO yet. So once this GPO gets processed, that'll go into my local Trusted Root Certification Authorities, and I'll trust that. So let's go ahead and close that for now. That's how you push it out with your GPO. You want to make sure all your systems have that before you start working with this. All right, so now just for testing, let's go ahead and create a client key. We've got a system called Server 1, and we want to trust it, all right? So just like we did for the root CA, let's generate our key. We're going to generate an RSA key. We're going to call it server1.key, 2048-bit, of course. Now we're going to make a CSR for this system. Now, some systems can make their own CSRs, and that's fine. You can use those. But in this case, ours couldn't. So it's going to prompt us for all these questions again. Chicago, Illinois, US. All right, so this system was server 1. So we're going to call it server1.client.local. All right, now we've got that CSR. And we can go ahead and look at that CSR. So I like to use SSL Shopper to do these types of things. So we'll pop over here to SSL Shopper. We're just going to copy this certificate request, and we're going to look at CSR decoder, paste it in here. We can see that we're requesting a certificate for server1.client.local. It's also going to have these alternate names, client.local, www.client.local, client.com, and these IP addresses. Now, why is that? We didn't specify that anywhere. Well, it's because we made that default configuration, and it's always going to use that and add those in. Now, maybe we don't want that to happen. Well, in that case, what we would do is remove this server1 CSR. Let's copy our OpenSSL CNF to test CNF. Right? Let's edit this guy. Let's come down here and just comment out v3rex. All right. Now, what do we want to do? We want to request a new CSR. And this time we'll specify our config file. All right. Whoops. What do I do here? Oh no. All right, so that was bad. I actually just overwrote our key. So let's redo that. Generate the key again. I'm hitting tab too fast. All right. And now, let's check that key. Or that CSR rather, sorry. And we would expect to not see those SANs. And there we go. We have no SANs anymore. So by default, we were using that OpenSSL.cnf because that's the system default. But when we don't want those, we can just use a different one. All right. Now let's go ahead and sign this. We're going to sign it using our CSR. That makes this certificate effectively not a self-signed certificate because we have a root CA that's deployed to all of our clients. So this will show up as trusted. So we're going to pick the CSR here. We need to specify our root CA that we're signing with. Specify the key for the root CA because you have to have the key to be able to sign. Create our serial. Here's the file we're going to use. We'll make it 1,840 days. And it's going to be SHA-256. Now we have a server1.cert. Well, oh, that's the one. So let's check this certificate. Certificate decoder. Paste it in here. And there we go. We can see that this is valid from June 3rd, 2019 to June 16th of 2024. It was Client Tech LLC is the organization. It's for server1.client.local and only server1.client.local. And the issuer was root CA from Client Tech LLC. So we know this is a CA signed certificate and it's for this server specifically. All right. Now let's say that we want to work with something like Call Manager. All right, and we need to have, or actually, let's skip that. This can all relate to a Cisco UC application, but let's pretend we're just doing a website. That'll be a little bit easier, and it's in line with how we created our config file. So we'll just get started. The first thing we need to do is, of course, generate our key. So we're going to call this www key, 2048-bit, just like normal. All right, now we need our CSR. We're going to get prompted for our questions. Note we did not specify a config, so we're going to use the default. Now this is www.client.com, our website. Let's check this CSR. We hope to see all of those SANs now. And we do. So this server, or this certificate would be good for www.client.com, client.local, www.client.local, client.com, 10.10.0.50, and 213.47.120.9. So if we browse to this site with any of these names and this certificate is there, it will be trusted because we trust the root CA. All right. Now, let's go ahead and sign the certificate. It's pretty much the exact same process. And let's check it. Certificate decoder. And we have client.com, but what are we missing? We're missing our SANs. Now, here's something interesting. Those SANs will not show up normally. All right. And that's because OpenSSL is going to strip those out, even though we had that open in there. All right. So what we can do is remove that certificate. And we're going to sign it a little bit differently. If we want to certify it until June 16th of 2024, which is 1,840 days. We do. Let's go ahead and sign it. Now it says that the request has been certified. Do we want to commit that change? Yes. All right. Now let's check our cert file. And now we can see client.com, client.local, www.client.local, client.com, and our two IPs. And we can see that the issuer was root CA from Client Tech LLC. And this is exactly what we want. So now we've certified this. And if we check our index file here, oops, we'll see some notes here. So we can see that on this date in Unix time, we certified an unknown certificate, and it was the first one we certified. Now we can also check our serial here. And we can see that the next serial number will be 02 because we used 01. All right, so this keeps track of everything. We know that the first certificate signed was www.client.com. We have some information about it, and that helps us to use our crow list to revoke things. And of course, when we do this, we also get our .old files to keep track of some of these things so we can roll back if we need to. All right, and that is it. You just take these certificates, load them up, and you're good to go.